There he is.
Hello. Sorry, I'm a bit late.
You're worth the wait.
Awesome. Looks like we have a lot of folks joining us. So we're just going to give it a couple minutes for people to trickle in and we'll get started. Okay, let's go ahead and get started. Seems like we have a lot of people here now. Hello, everyone. Thank you for joining us. My name is Bree Rogers. I am the Digital Marketing Manager here at Cloud Foundry Foundation. Joining me today are Troy Topnick, Vlada Ivanov, and Eric Promislo from SUSE. Obviously, today is all about Cloud Foundry for Kubernetes. What is the community doing to bring the same great Cloud Foundry developer experience to Kubernetes? What are the differences between KubeCF and CF-for-K8s, and how can I hit the ground running? We'll dive into all of that shortly. Real quick, I just wanted to go over a few housekeeping items. Today's session will be about an hour long. We will have about 40 to 45 minutes of content, and then we'll dive into a Q&A session. Throughout the presentation, you can put questions into the Q&A panel, and we'll address the questions at the end. If for whatever reason we encounter any technical difficulties, please use the chat function to let us know. Today's session is on demand, so you can access it at any time after this. Yeah, that's really it. So without any further ado, let's get started.
Hi, Bree, thanks. So we're here to tell you all about Cloud Foundry on Kubernetes, the things the community is doing, the things our company SUSE is doing to deliver Cloud Foundry on Kubernetes. And so let's introduce ourselves. We'll start with Eric.
I'm Eric Promislo, Senior Software Engineer with SUSE. I've actually been working upstream on various Cloud Foundry projects since December 2016 as an open source contributor. Before that, I worked on Staccato with at the Active State startup and then HP Enterprise.
I'm Troy Topnick. I'm a product manager for SUSE Cloud Application Platform. I also head up the Cloud Foundry Community Advisory Board and currently heading the Extensions PMC. And yeah, like Eric, I've been working on Cloud Foundry for quite a while in some capacity or other. Yeah, that's me. And Vlad?
Hey, I'm Vlad. I'm the architect for Cloud Foundry at SUSE. I've been working with Cloud Foundry since 2011, I think. So again, for a long time. And yeah, it's been a fun ride.
Sure has.
Yep.
So I want to frame this, put on my product manager's hat for a minute and talk about why we're in this game to begin with, what we're trying to deliver to customers. Customers want the Cloud Foundry promise. They want to move their applications to the cloud. You know, our old mantra of here's my source code, run it in the cloud for me, I do not care how. So Cloud Foundry has always been able to do that. That is the promise of platform as a service. But more recently, the industry has shifted away from virtual machines into containers, and people want to shift their application workloads into containers rather than VMs. And specifically, in more recent years, they want to do this in Kubernetes. And that has become a signal that was loud and clear a couple years ago and is even louder now. So SUSE took an early lead in this direction, but now the whole Cloud Foundry community is on board with Kubernetes as the de facto platform for scheduling containers. And they want to be able to make this transition to run their code in the cloud on Kubernetes in containers easily. And that's where Cloud Foundry comes in, especially if you've worked, you know, with the very steep learning curve that Kubernetes has, which can be intimidating to end user developers. Cloud Foundry has solved that part of the problem already, and it can provide a really nice on-ramp for developers to do this. Now, I'm, as I mentioned, the product manager for a product called SUSE Cloud Application Platform. And we had to solve this problem of getting our software, or in fact, the Cloud Foundry software, onto Kubernetes before we could help our customers get their software onto Kubernetes. So we had to solve the same challenge ourselves before we could solve it for our customers. And so we did that with the first version of Cloud Application Platform, which was based on an open source project called SCF, which was short for SUSE Cloud Foundry. And what it did was take a CF deployment and manually massage it with a little bit too much manual effort into a Helm chart that we could then give to users, give to end users, and they could install relatively easily on Kubernetes. But the landscape has been changing with more people in our community involved in developing for Kubernetes. Now we're faced with a landscape where we have to put together, certainly with KubeCF, but also CF-for-K8s, a number of different components from the upstream teams into a usable distribution of Cloud Foundry for Kubernetes. And to that end, there have been 2 projects that were launched to make this happen. KubeCF goes back a little bit longer because it traces its roots to SCF, but also CF-for-K8s. I think it's important to point out that though these projects were started somewhat independently, they're not in opposition. And we've done a lot of work as a community, as the Cloud Foundry community, to make sure we're all pulling in the same direction. So I just wanted to set the stage here a little bit about what the differences are, and then we'll get into sections that Eric is going to present on CF-for-K8s, and Vlad's going to present for KubeCF to really go into depth on the difference of the approach. Right now, KubeCF provides a certified Cloud Foundry application runtime distribution, passes all the acceptance tests. It is functionally equivalent to a more traditional BOSH-based Cloud Foundry release. Whereas CF, and it uses a lot of the tooling that was created to manage Cloud Foundry foundations, that is BOSH, to make that distribution. CF-for-K8s, or Cloud Foundry for Kubernetes, is I wouldn't say a rewrite, but a reimagining of a Cloud Foundry with what we're calling Kubernetes idiomatic releases, things that really take advantage of Kubernetes features by forcing us to look at how Cloud Foundry itself is built on Kubernetes. And so this is, I'm calling it the proving ground for Kubernetes idiomatic releases. The great thing about how these projects can work together from my perspective, working more on the KubeCF side, is that we can actually adopt these Kubernetes idiomatic, or you'll see them called Kubernetes native as well in this presentation. We can adopt these components as we go. And I think that's how we're going to start talking about this, is to talk about what's in KubeCF now, the state of it, and just take a look at what the upstream community is building and how we plan to bring it in. So I'm going to actually hand it over. First I want to say, in any other community, this probably could have developed into a fight. Like 2 different implementations of Cloud Foundry on Kubernetes would have been disastrous if we weren't all as collegial as we are. But we have a really good relationship amongst the various companies that are partners in Cloud Foundry, amongst the contributors. So we were able to realize the benefits of both approaches and pursue them both at the same time and have them feed off each other. And that's what this presentation is about. So without any further ado, I want to hand it over to Vlad, who's going to tell us about KubeCF and Quarks as well.
Sure. So what do we want to accomplish with KubeCF? So as Trey mentioned, the obvious part, which is deploying Cloud Foundry on Kubernetes. But how do we want to do that? So historically with SCF and now with KubeCF, we're doing that by leveraging BOSH deployments. So we have this BOSH deployment manifest that we give to an operator, and all of that information is converted into Kubernetes native or idiomatic resources, things like stateful sets, secrets, config maps, services, etc. The operator that we've built, or the operators that we've built in the Quarks team have actually grown beyond just BOSH, so they can be used completely separately from BOSH deployments. And we have Quark Secret being used by the CredHub team. So we too want to move away from all of these BOSH artifacts, and we want to all converge onto a simple distro of Cloud Foundry that you can build with minimal effort so that we can all focus on delivering features faster. Right now, I'm not sure if we have links maybe in a later slide, but you'll see that KubeCF is a separate repo from CF-for-K8s. We don't want that to be the case forever. We want to converge into the same repository and support everything in the same location. It might take us some time, but that's where we want to go. So like I said, everything should be Kubernetes native. We don't really want to convert BOSH releases when we actually have all the component teams creating Docker images that should run natively on Kubernetes. Finally, one big difference of KubeCF from CF-for-K8s is that we still support Diego. So when you deploy KubeCF by default, if you don't turn on Irene, you get Diego cells deployed. Again, we don't want this to be the case long-term. We want to remove Diego and just have Irene, but we recognize that we should still have both for a while until Irene is proven to work just as well as Diego. So where are we now in KubeCF with our goals? We have a few components that are native, so that don't use BOSH releases. The database that we kind of embed into KubeCF, if you don't have an external one, that one is native. Irene and Irene X extensions, they're all native. So Helm charts and pods and stateful sets. No BOSH releases there.
I'm just going to pause just for a second and say, when we're talking about Kubernetes native in this sense, we're talking about the components that we take into the project to build the release, right? This is, as opposed to getting a BOSH release, we're actually pulling in
right.
things that were built directly on Kubernetes.
Yeah. Yeah, I don't, hopefully I haven't confused anyone. We're not talking about non-native components at runtime. At runtime, everything becomes a native Kubernetes component. It's just about what we consume in the distribution itself to give you that Kubernetes experience. Yeah. So UAA is in progress right now. The UAA team actually has Docker images for UAA, and we're integrating that right now. After UAA is done, yeah, next slide, please. We'll look at CAPI and all of the other components. So one key differentiator between KubeCF and CF-for-K8s is Helm. We like Helm, and we want to deploy Cloud Foundry on Kubernetes using Helm. And I think that is the key differentiator, because as you've probably noticed, we all want to run the same components. So in the end, we'll all run the same Docker image for UAA or for CAPI. We'll all be running the same KPAC and so on. The differentiator is, how do I install? What's my experience for installing? And right now, we want that experience to be Helm in KubeCF. If you don't know, Helm is a part of the Cloud Native Computing Foundation. It is, so it was incubating for a while, but it's now actually part of CNCF. You can see that there are officially maintained charts out there from AWS, VMware, Rancher, Microsoft, SUSE. So we're in good company there. I don't think Helm is going to go away anytime soon. From internal discussions in the community, there have been concerns about dealing with CRDs, but we feel that that's possible. So if you, I mean, you can search for docs on how CRDs are special when you deal with Helm. And finally, even CF-for-K8s actually does use Helm. So that kind of gives us extra confidence that, you know, Helm is here to stay, and it should be a fun and useful experience when deploying CF to Kube. So I'm just going to a bit try to explain how we want to move the KubeCF project forward, and actually do it at a pace that that's, you know, fast enough to keep up with everything that's going on in this space. So we started out by thinking, hey, wouldn't it be great if we could mix and match everything that you could possibly do with KubeCF, with Irene, with Diego. Wouldn't it be nice if I could say, I want to deploy Irene, but I want a native UAA, but I don't want a native routing component yet, right? So I don't want Istio with Irene, I want the Go router with Irene. But what if I want Istio and Diego? Could that be possible? So wouldn't it be nice if we could mix and match all of these, you know, this plethora of options? So we decided that maybe it's not that good of an idea to do everything possible, and we should just conceptualize two worlds for KubeCF, one that's Diego based and one that's Irene. Or if it's easier to think about it, you could call it Bosch or native. And then we can keep Diego close to the Bosch world. So CF deployment is still being maintained. We can keep this Diego world close to the Bosch world. So everything that's being tested and deployed by so many people in the CF deployment world, we would do the same in KubeCF with Diego. And then we can keep Irene, the Irene world, close to CF-for-K8s. So whenever CF-for-K8s has high confidence that Istio is working correctly and that KPAC is working nicely, we will move our Irene implementation in KubeCF to work with those components. That way, we reduce the test matrix for KubeCF, which is already quite large, and you know, we just make sure that we have the best of both worlds, we hope.
Jules Friedman would call that that latter category the Irene-verse, but I don't know how the other teams would react to that.
Yeah. Right. So a quick status of Kubernetes native components. So both in the Diego and Irene world, CAPI will be can be native. So we have, I think, a CAPI image right now for that's being deployed in CF-for-K8s. We still use the CAPI release in our setup. Diego will be replaced with Irene and Kubernetes itself. Routing and NATs will be replaced by Istio in the Irene world. Logaggregator is being replaced with Fluentd. UAA stays UAA. The Blobster goes away, as far as I know, in favor of things like MinIO. In our case, we still have bits, but that will go away. And you could, once KPAC is there and fully working, and I think it is, maybe Eric can tell us more about that, you'll be able to use an arbitrary registry for images like Harbor. CredHub stays CredHub. We don't know about the autoscaler. If anyone's worked with KubeCF, you'll see that we have an autoscaler component that you can turn on. I don't think we've discussed as a community how does autoscaling look with the Irene world and Kubernetes. And then all of the build packs will use Paketo. Things that we want to watch out for when we implement all of these things is one thing that's hard is communication between components and networking. So when we switch out components in favor of native components, we have to pay very close attention to networking and configuration of certificates, passwords, and config files. And we always have to maintain an upgrade path. So yeah, I encourage everyone that's playing around with KubeCF and CF-for-K8s to try and take these installations to interesting places in these domains. So if you want to do certificate rotation, if you want to deploy multi-cluster, please try those things out and let us know what you find. Because these are the difficult parts of deploying on Kubernetes. And then another thing that we do and have to take care of is that we maintain the ability to run on different OS images and on different stacks. If you remember in the Bosch world, everything used to have a stem cell, meaning SUSE could have a SLE stem cell so that we can provide people with the SUSE experience. Upstream has an Ubuntu-based stem cell. So we want to keep that flexibility inside the ecosystem. So when UAA has a Docker image, we should all be able to build that Docker image with whatever, with whatever flavor of Linux we want. So for us, that would be SLE. Upstream might be Ubuntu, etc. And I think that's all I have, right?
Yeah, thanks, Bud. So in introducing Eric's section, I just want to say that as part of this thing of trying to work well together in the community with these two projects, SUSE asked Eric to move over to the CF-for-K8s project so that we could get a closer connection and we could always know what's happening in that project and vice versa, that there could be a bit of a conduit between these two projects, and that's been really helpful. So I want to thank Eric for being part of that team and for giving us a little window into what's happening in the laboratory.
Thanks, Troy. Yeah, I joined the release integration team around March, right at lockdown time. And that used to be all CF deployment, and it seems about 10% of our work has been on CF deployment and the other 90% on integration development for CF-for-K8s, running the pipelines. I wanted to follow Vlad's comment on upgrades. We have multiple upgrade scenarios in our CI/CD pipelines just to test what happens in different scenarios. And they often break, yes. it's a key area. Okay, so I'm just going to give an overview today of what's going on in CF-for-K8s. This is a high-level architecture diagram. It follows a lot of the KubeCF architecture as well, to not too much of a surprise. I've partitioned it into these areas where the user applications running on Irene on Kubernetes are in the top layer. The Cloud Foundry layer splits into two, where there are the CF components on the left side. So Cloud Controller, actually I'm gonna, the next slide goes into more detail on what they do. The high level is all those teams as part of the CF-for-K8s initiative started to deliver their software in containers as well as BOSH releases. So it was easy for CF-for-K8s to consume them, basically consume the container and consume the configs, and you're done. And I'll be going into that. And similar to KubeCF, we support Postgres by default as the internal database, but people can supply their own. And in fact, SAP recently made an external pull request to support an external database. And there were a few hiccups there, but that's in there now. MinIO is the default blob store, but you can provide your own blob store as well. So that's another where you can just plug in your own software. Supposedly, I don't know if you can do the same with Istio because it runs as sidecars. It gets injected into sidecars for almost every components pod. And like we're using FluentD to do a lot of what the Logaggregator used to do in terms of just getting logs from the various user and system containers into something that can be consumed, but that consumption part is still done by the logging component. And then finally, this all sits on top of Kubernetes. Next slide. Thank you. So yeah, I looked at what do people want now, and they want a structured organization of modern app deployment technologies, like the days of just pushing your app and writing your own monitors and your own logging. Those are long gone, and it's since Cloud Foundry emerged almost 10 years ago, people have realized there are better ways. And then Kubernetes has just had us turn on stream, and like Troy said, Susan did it earlier. In fact, the Cloud Foundry CF-for-K8s, the initiative I think started last fall 2019. So it shows you how quickly you can go when you're, when you have everything in place. So the user-written apps, they're delivered as OCI compliant containers. You could use Docker. We mostly are using the Google Cloud Registry, which uses same component containers. They're all OCI compliant. And then, like I showed on the diagram before, it's a mix of Cloud Foundry and other open source technologies. Okay. So diving deeper into these, you're probably familiar with most of them. The Cloud Controller is still the main controller of the system. Basically, just maintains desired state, what the operator wants. App servers, for example, do you want to run? How many, and for the developer, how many instances of an app and which apps do you want to run? And it keeps that all in sync. The router connects the world to the apps, hopefully in a safe way, logging metrics, reports things. UAA is still around, and in fact, the UAA team basically, like I said, they are now packaging their software as a Docker container or GCR container rather than as a BOSH release. Vlad also mentioned KPAC. I should point out that, well, KPAC and PAC are being used a lot here. PAC is, they're basically the same thing. PAC is a command line utility to package software as a container. KPAC uses more of a Kubernetes type YAML approach. So a lot of the technologies between the two products are the same. And then finally, we're using Irene to run the apps on Kubernetes. And then as I've gone through here, I did mention KPAC. Yeah, we've discussed these in enough detail. So one area where there is a divergence between CF-for-K8s and KubeCF is in the deployment technologies. So while KubeCF is using Helm, I don't know what the history is because I wasn't around then, but CF-for-K8s has, instead of using Helm for a lot of things, it is using Helm to process some third-party tools. There are a suite of Kubernetes tools. They're all housed at K14s.io. The 14 is the number of characters, including the space between the K and the S. The two I'm going to focus on today are YTT and CAP. And those are the real differentiators in some way between the two technologies, two approaches. So YTT stands for a YAML template tool. It's often thought of as a Helm replacement because it takes input like smart templates and expands it into raw YAML to be fed to Kubernetes, the Kubernetes engine. The one big difference is that YTT is actually YAML aware. So YAML, if you don't know, relies on indentation to specify the structure. So you could have a parent node, and then its child nodes would be indented by usually 2 spaces in the document. And if any of those child nodes have children themselves, they're indented another 2 spaces. When you look at Helm charts, sometimes you see indent directives. Like if you look at the Nginx Helm chart, there is indent 10, indent 8. People are saying, I need these many spaces. With YTT, you don't do that. It's because the YTT engine is actually based on a dialect of Python called Starlark. And so you can have functions like Python-like functions in your YTT code. And the code they emit it's just YAML, but the engine knows where to indent it. So that frees the user from having to basically count spaces. Again, they get good things that you get from Helm as well. So you're not repeating yourself. You can templatize similar objects. And I'm not going to run it, but I think when you run YTT against the CF-for-K8s config directory, you expand about 4,000 lines into 15,000 lines of raw YAML. There is a YTT sandbox tutorial at the link I have down there. It's easy. If you just go to k14s.io, you'll see a lot of pages and a lot of links, and you can click to YAML. So if you want to explore the sandbox and the tutorial, they're one and the same. The first tutorial just has simple YTT, which is actually YAML, and then it adds more variables and more logic. And then CAP, I think of CAP as an ordered kubectl. So it does a lot more than kubectl. So kubectl, you just throw some YAML at the Kubernetes engine and say, here, process this. CAP actually queries the current system, and then it looks at what the current objects are asking to do, and it determines a diff, and it interactively shows you the diff. So before you press return, you can see, oh, do I really want to delete those objects? No, I made a mistake. And you'll say no, or Control C. So it gives you that interactivity, which you can, of course, turn off in like a CI/CD workflow. It's also, this might change, but right now it's better at deleting Kubernetes objects because if you just remove an object from a YAML directive and use kubectl, sometimes the object doesn't get deleted. CAP determines that it has to. CAP also builds a dependency graph. So for example, it says, well, I need to have the database running before I can run the cloud controller. So it actually will get the database job started before it kicks off the cloud controller job, for example. So then if you're looking at the kubectl output, you see fewer crash loop backing off errors. This is the link. Troy, do I have, oh, you're getting a drink. Do I have time just to explore right now? Because I know we want to have a Q&A. Okay, sure.
5 minutes if you wanted to show something.
Sure, yeah, I'll just show a couple of things where what it looks like here. I'm going to share my screen. Okay, so it's asking me to stop your screen sharing.
Done.
Okay. And I have many.
Should point out here that Eric is the inventor of Tab Hunter, the tab management utility.
Yes, but
you're probably finding your way through many.
I have many desktops, and this is it's not showing me what I want to. Let me just try this. Yeah, I need a desktop share thing. Here we are. Is that?
Yeah, we can see your desktop.
Okay.
You're going to need bigger fonts though when you
sure. So you can see me go to CF-for-K8s?
Yep.
All right. Okay. How is that size?
That's just perfect.
Okay, great. So probably the docs, if you want to go and explore this, the docs have deploy files for various scenarios. The main interesting ones are deploy local if you're using Kind or Minikube, deploy in general. So I'll leave you with those. The key area for how CF-for-K8s is structured is in this config area. So we get, these all look very familiar now. The CAPI team basically, it submits PRs directly into this YTT-lib CAPI K8s release. And so that's their raw code. We don't have anything to do with that. We can configure it a bit here. So here's some YTT. And we're just, this is the configuring for the various parts that CAPI complains about. So for example, you want to keep your packages on your API on the CAPI server in CC packages. The passwords, this is more declaring the passwords rather than putting them in. I'll show how that goes as part of the deployment. Config optional is where these are things that we've added or third parties have added. So for example, if you need a metric server because you're using an IS that doesn't provide one, this YAML code will define one and install it. The one I put in, if I was going to show, oh, of course, it's on my local machine. Yeah, the config, the doc. The next slide that Troy was about to show before I moved over here was how to deploy it. And there's a very simple command line, which I can show here in deploy, sorry, docs, and then deploy.md and search for cap. And here we are using YTT. So you always would, -F is how you point YTT for input. So you're always going to point it to the input. And then you would have a YAML, a values file where you would provide your passwords, your certs, any other configuration that you need. And we're revisiting that because it's still fairly, either use a hack script to generate that, or you can craft it by hand, and that's a little longer. And then this is the temporary YAML file, and there's the cap command, which is just running that. I just wanted to demonstrate how we're using it. So for example, I have 2 API servers running here. And I know definitely you need a better font size. Is that better? So we're just running the CF, we're just looking at the pods that are in the CF system. So set API server account.yaml. So here's the power of YTT, where we don't really need, we don't really need to know where in the code we are defining the number of replicas. There are apparently 2 here because we're running 2, but this is an overlay that will let us change it to 3. I'm just going to do this to show you what the usage is like and also how long it takes. So the command line here, we're now running ytt-f. We're running it inside this to avoid the temporary file. So I'm going to run it, I'm going to point ytt to the config, also to that set API server, and the command line's cut off, and then my values file. So, which is just a variable, but that contains all the certs and things I care about. The -c at the end of cap is going to prompt me with the changes that are necessary. And so it's calculating the differences. It found some other certs and things need to be changed. I don't know what's going on there, but there's a lot, and there didn't used to be so many. But the key here is the old count of the replicas was 2, the new count is 3. So I will just accept it. And then if you turn over to the right-hand screen and watch what's going on, cap is very chatty as well. It has already created a new pod, new API server. It's initializing it. After 10 seconds, it's running it. Cap over here on the left is, it just was querying everything to make sure everything's running, and it is. So that gives you an idea of the workflow. Troy, I think we can go back to the slides now.
That's assuming I can find my way back.
Yeah, exactly.
So that's the one that you were showing.
Yep.
I thought I'd open it up now for questions. So if you haven't put any in the chat yet, please go ahead, or in the Q&A section. But yeah.
Sorry, I realized that I also wanted to show at least a screen of how KubeCF is running.
I was about to maybe pull that as well. Let's show the alternative approach.
Yeah.
Tell me when you're ready to go. There we go.
Sure. So I just wanted to show, this is a KubeCF installation on a local client cluster that I have. This is K9s, showing all the pods in the system. And you'll see things that you already know about here, right? The API, Bosh DNS. We just run core DNS to have an easier time of dealing with certificates in the Bosh world. Here you have Diego cells, log API, all the log stuff, nats, routing, and so on. These are all stateful sets. You can see them here. And if we look here, I'm going to look at a CRD. So when you install the Quarks operator, it actually sets up new resources that you can use on your Kubernetes cluster. One of these is a Bosh deployment. We see here that we have a KubeCF Bosh deployment whose age is 2 hours and change that I deployed for this webinar. I think I can actually show you all the CRDs that we have. Yeah. So when you install the Quarks operator, you get a CRD for Bosh deployments, and then Quarks jobs, secrets, and stateful sets, all of which are independent from Bosh, and you could use for other things as well. So they all have interesting features. I think if you want to learn more about that, you can find docs online. Maybe they can be useful.
Specifically, we talk about secrets being used by CF-for-K8s as well.
Yeah.
Or parts of CF-for-K8s.
Yes, these are all Quark secret definitions, and each one of these defines a certificate or a password that needs to be created, and so on. Yeah, I think that's it. If there are any questions related to this, please let me know and I can bring this up again.
And actually, I wanted to mention, in the spirit of us all getting along, CF-for-K8s is replacing its current form of dealing with secrets inserts with quark secrets.
Yeah, it was
Excellent.
something when we saw people struggling with that problem, which we had to struggle with as well. It's like, wow, well, we've got this code you're perfectly welcome to use, and it could be useful for you. So even though the context is very different, you know, CF-for-K8s is not in the business of transforming Bosch releases into Kubernetes releases. The problem space is the same. The things that Bosch had to do that weren't, the features were not available in Kubernetes, still are not available in Kubernetes. That functionality is now provided in this operator, which, as Vlad said, is now generally applicable to problems in this space in Kubernetes land. I'm going to sort of guide us towards some questions. I think we've had a few come in. Bree, did we see some in the Q&A that we want to?
Yeah, there is one. I tried to deploy CF-for-K8s on a 5-node AKS. Sometimes I get strange timeouts from CAP, and I don't get why. So their message is also in the chat. If you,
I can't see the chat, but maybe Eric can.
I go ahead, Vlad.
Sorry, I just I'll leave it to you. I just thought that maybe this is a question that's good for Slack.
Yeah,
exactly.
Sure.
I just typed that answer because I don't have all the info on this, and if I did, it would probably drag on too long.
Yeah,
I don't think it's a simple solution, but
I think I'm glad to see we got people that are that into it, that they're already digging around. I actually came up with some questions that I wanted to ask just to get the discussion going, and we'll circle back to questions from the audience in a bit. I wanted to hit Eric with, although you kind of answered this before, why CF-for-K8s did not use Helm. I mean, we're big Helm fans in the KubeCF team. Why YTT was preferable? I could see why the CAP thing is very attractive. KAPP.
Yeah. So I wasn't around on that team. I was on a different team when all that the CF-for-K8s started. I was actually on the CLI team, which is we were kind of oblivious to the whole thing there, because the CLI, the command line interface, the CF command has not changed at all, because this is all back-end work. But when I saw how it worked, and I just have familiarity as a user for Helm, whereas I've learned a bit about YTT. I think Cloud Foundry, the community has a lot of experience with manipulating YAML, manipulating config files. First, there was the SPIF tool. And when we joined this, SPIF was already being deprecated. And then we dealt with ops files in the CF deployment world, which is another way of taking YAML and applying changes to YAML in a very declarative fashion. And it looked to me like they wanted to continue, they wanted to build on that experience going into the Kubernetes world. And the idea behind the YTT was to take that technology, take that, what they had learned, and just build a general purpose tool. And I believe YTT is being used outside CF-for-K8s and outside the Cloud Foundry environment. It is an open source tool.
Yep.
And then when you separate the template processing with the deployment tools, you can suddenly do more things with, for example, workflow. And we actually do have in our CI/CD, we do have cases where we run YTT just to create regular YAML. And we use that mainly, there is a lot of repetition in our pipelines. So for example, if we're going to process a new container from one of the teams like UAA or CAPI Logger or Logger, it's very similar. You get the new image, you consume the image, you deploy it, and you run smoke tests. And we replaced a lot of repetitive code with just a YTT function that we process and throw to the pipeline. So, and I just look at that as sitting on top of almost 10 years of experience in this area. And CAP I've just used. I haven't dived in as deeply into why CAP was built. In other words, I haven't watched, I haven't read the white paper. I haven't watched the videos on that as much as YTT, which I found interesting because it's an area that I've worked on as well. Just code generators and code manipulators.
Okay, I just sorry, sorry about the different, hopefully you can still see the slide. I want to get to an audience question, and it's, we are currently creating a DR environment with KubeCF on AKS, and things are progressing smoothly. We have done some POCs with CF-for-K8s on AKS. Since we currently use open source Cloud Foundries for some SaaS products in production, we feel comfortable using KubeCF. Excellent. Do we have to move over to CF-for-K8s down the line, or both of these will be offered always? That's an excellent question. And I'm going to give that one to Vlad, or I will try and answer it first, and Vlad can expand. You shouldn't have to move over to CF-for-K8s unless that's something you really want to do, because the components from the upstream teams should be the same in both. It should, the goal is that we will converge these projects, and even in the current case, the medium-term goal or the shorter-term goal is to make sure that we have the same components in both distributions. So unless you prefer the packaging approach of CF-for-K8s, you shouldn't have to switch from one to the other. Yeah. I think it's a great question. Vlad, anything further on that?
Yeah, no, just like you said, if you don't want to switch away from KubeCF, you don't have to. We'll be supporting it for the foreseeable future.
Awesome. So Helm 3 came out in the midst, actually before KubeCF came out, but in the midst of SCF. Oh, that's going ahead there. I didn't want that to do that. Vlad, does it help us out at all in terms of some of the challenges that we've hit previously packaging things for Kubernetes?
It does seem like CRD management will be easier. We are thinking about moving to Helm's new CRD management model, where you put your definitions in a special folder that gets managed by Helm. In Helm 2, we decided to make the CRD management part of the operator. So when the operator starts, it looks at what CRDs are installed. It'll try to update them and so on. But we think that, you know, just working with CRDs and dealing with versioning there, as Helm says, should work fine. And we're trying to also touch base with upstream about this. So,
right on. We talked about Quark secrets. I thought and we talked about, actually you covered it in your slides earlier about the challenges that you see for KubeCF, some of the stuff coming from upstream. I did want to mention IreneX, because this is a project that SUSE has just contributed to the Cloud Foundry Foundation, which is something we built around Irene. Can you tell us a little bit about that, Vlad, and how it's significant?
Sure. So as you all know, Irene allows us to remove Diego and deploy the applications that you push to Cloud Foundry on Kubernetes. But we don't have all the features that we had on Diego yet with Irene, right? So for example, being able to SSH to your application, or persistence support are two things that we definitely wanted with Irene as well. So we thought, okay, since Kubernetes Well, there are two things that we were thinking about with this. First, the Irene team wanted to make sure that it defined its boundaries properly so that it doesn't try to do too much, right? So you don't want the Irene team to be responsible with everything that is even remotely related to running an app. Otherwise, they'd have to build all of Cloud Foundry, right? So they had a specific thing that they wanted to do well, which is to run applications on Kubernetes. So then we thought, what mechanisms do we have to try to extend that behavior? And Kubernetes has a lot of these, right? You can do webhooks, both for mutation and for validation. You have watches. There's so much you can do to try to expand the behavior of Kubernetes. So we wrote this library, you could call it, that allows you to add on to Irene. So it's essentially a Go module that has all this nice stuff in it that allows you to quickly expand the behavior of Irene. You could write a hook that mutates an application pod and adds an environment variable. Or like we did, we wrote a persistence broker that allows you to consume Kubernetes storage classes as persistent services. Another thing that we did is implement SSH using this. So you can now do CF-SSH if you have Irene. We also needed a slightly different, a different way to do logging because we had more ways of deploying KubeCF on on a variety of Kubernetes clusters.
Yeah.
And the Fluentd approach
didn't work on all of them, as I recall.
Yeah.
And it's good to point out also that this IreneX used code from the Quarks project.
Yeah. So the Quarks project gathered all of this knowledge about how do you do controllers, how do you do hooks, and all of these things. How do you deal with the controller runtime library from upstream? And all of this knowledge is very helpful for IreneX. So that's also using some of that code base. And now IreneX, I think, is being adopted by the Irene team. So it'll actually be maintained by Irene.
That's great. Okay, well, unless we had, and Bree, tell me if there are more questions that I'm just not seeing, but just to wrap up, my job as a product manager would not be complete here unless I talked up our SUSE Cloud Application Platform 2.0, which was launched at the Cloud Foundry Summit. It includes our SLE build of KubeCF 2.2.2 and Quarks 4.5.6. We have just launched Stratos 4.0, which can be added to this. It's part of the officially part of SUSE Cloud Application Platform 2.0, and that's coming out this week, I believe, along with Stratos metrics for tracking things. And we will soon have an updated mini broker for deploying services for Cloud Foundry using Helm charts from upstream. And you can find out more about this wonderful product on the SUSE website there. So I want to thank Vlad and Eric so much for bringing some technical depth to this talk and for sharing so much about these two projects. Hopefully we've covered how we've got really great collaboration going in the upstream community and amongst the companies that work on contributing to Cloud Foundry. So thanks very much. Bree, did you have anything to close?
No, just thank you everyone for joining us. And like I mentioned before, this will be on demand, so you can come back to it anytime and we can send out the slides. Everyone here is available on our Cloud Foundry public Slack if you have any questions. And with that, we can wrap this up. So thanks everyone.
Thanks.
Thank you.
Bye-bye.
Cheers.